naming of molecular and ionic compounds. So chemists use rules and conventions to name different compounds. So it's just like any language. Some of it's going to seem pretty Greek, and literally some of it will be Greek, and other times it's going to seem not very short. But we're going to get through it, and it's going to work, and we're going to make it work for us. So let's start with the names and formulas of single atom ions. So first off, what is an ion? We already talked about if you take any atom of an element, like lithium, it has 3 protons. Well, what if it has 3 electrons? It's neutral. What if it did not have 3 electrons? What if it had more electrons? Then it would be negative. It would be an ion. What if it had less than 3 electrons? Well, then it would be positive. Again, it would be an ion. So an ion is created when the number of protons does not equal the number of electrons. So we have too many electrons, it'll be negative. Less electrons than protons, it'll be positive. Okay. Where are the metals on the periodic table? The metals are pretty much this entire periodic table. There's the metals. The nonmetals, here's the nonmetals. Okay? When it comes to ions, metals always form positively charged ions called cations. And nonmetals always form negatively charged ions called anions. So these are always going to have a positive charge, and these are always going to have a negative charge when forming these ions. Okay, here's some helpful hints in naming these positively charged ions called cations. Elements of group 1A can only have a charge of, well, just look at the periodic table, 1A. So all these elements can only have a charge of +1 because they're in group 1A. So for example, sodium, what ion would it form? Na+. A lot of times they don't write the 1, they just write a plus. 2A, well, same idea, +2. So all of these elements in group 2A form +2 charged cations. So magnesium would form an ion of +2. This would be in a magnesium atom. Now it's written as a magnesium ion. Group B elements have name and charge in parentheses to write their ions. For example, iron 3. So that would be iron with a +3 charge. So all these group B elements, all right, group B, here's group B, here's group B. All those form cations, and you just write the element name followed by the charge, the positive charge, in Roman numerals, right? For example, V5, that would be vanadium, Roman numeral 5. So there's only one cation left, ammonium. We just have to know it. This is what we call a polyatomic ion, and there's going to be some of those that we need to know. Helpful hints for memorizing names of anions. Okay, remember the anions now? They were just these nonmetals. So they're always negative. How do you name them? What I'd like to do is just count over to the noble gases. So if I have F, what charge can it take? It's only 1 away from the nobles. So it can only be a -1. Carbon, we get carbon. Count over to the nobles for carbon. 1, 2, 3, 4. So carbon, again, it has to be negative. That's going to be -4. Nitrogen, what ion would it form? It's a nonmetal, so it has to be negative. -1, -2, -3. So just always count over to the nobles. And how do you name these? You pretty much add "-ide" to the end. So instead of writing fluorine, you'd write fluoride. Instead of writing carbon, you'd write carbide. And for the nitrogen anion, not nitrogen, but nitride. So that's how you write the single atom anions. So right now, all we've talked about are ions that are single atom, or anions that are single atom. But life isn't that simple. So we have these polyatomic ions, and they're all in this table. Know their names and formulas. We have acetate, ammonium, carbonate, chlorate, chloride, chromate, cyanide, dichromate, hydrogen carbonate, hydroxide, hypochlorite, nitrate, nitrite. Notice how in some of these, they're very similar, just the 8 goes to an ite because there's one less oxygen. Notice that? NO3 to NO2. Perchlorate, permanganate, phosphate. Here's another one, sulfate and sulfite, one less oxygen. The last one, thiosulfate. So know the names and formulas of all those polyatomic ions. You can make flashcards. There's some ideas here on apps and things so you don't have to make the flashcards, just they're already made for you. So try those out. Naming ionic compounds. An ionic compound, what it is it has a cation and then an anion. And it's those positive and negative charges that hold this thing together. Okay, and they're crystalline. So naming these compounds, they always have to be neutral. And that's going to be a helpful hint in figuring out how to write their chemical formulas. But we name all ionic compounds by naming the cation first and then the name of the anion. For example, calcium chloride. Now remember, calcium is Ca, and chlorine, is Cl. What we need to do is we need to know the subscripts. How many calcium atoms are there for every chlorine atom? Or how many chlorine atoms for every calcium? What is the formula for this ionic compound? The trick is the charge. So calcium is in group 2. So that has to have a +2. And chlorine, it's a halogen, it's 1 away from the nobles, so its charge is a -1. Now all we do is make the charges be the subscripts. Move that charge down there, and move that charge down there. So it's going to be calcium with 1, and the chlorine with a 2 subscript. Calcium chloride is CaCl2, and most often they don't write the 1s. So that's usually what it looks like. What's an easy way to identify an ionic compound? So we always name all ionic compounds this way. So it's really useful to know that you're looking at an ionic compound. And the hint is if you see a metal. If you see a metal, it has to be an ionic compound. So where's the metal? The metals are this entire periodic table pretty much. Those are the metals. If you see one of those, it has to be an ionic compound. Then what you do is you name the cation, then you name the anion. So if we are just combining these, they're going to be molecular compounds. They're not crystals anymore. These are molecules that are held together with chemical bonds. They're very, very strong chemical bonds. They're called covalent bonds, but we'll get to that. Now, to name binary molecular compounds, binary just means 2. So we're only going to figure out how to name compounds that look like these, right? They contain just phosphorus and oxygen, or H and O, or S and O. So those are called binary molecular compounds. So not only do you not see a metal, but all you do is you see 2 different nonmetals. Those are the type of compounds we're going to name. How do you count to 10 in Greek? We have to know how to count to 10 in Greek. We have to know how to count to 10 in Greek in order to name molecular compounds. So, how do you say 1? Mono. 2, di. 3, tri. 4, tetra. How about 5? Remember your geometry? Penta. 6, hexa. 7, hepta. 8, octa. 9, nona. And 10 is deca. So how do we name them? Molecular compounds consist of naming the first element, then adding IDE to the second element. Greek prefixes are used to indicate the number of each element in the molecule. So we have how many sulfurs? 1. So mono, sulfur. How many oxygens? 2. So di. And then don't write oxygen, write oxide. So again, count to 10 in Greek first. How many phosphorus? 4 of them. So you'd say tetra, phosphorus. And how many oxygens now? 5. So penta. Sometimes they drop off the A, so you can write pentoxide. But if you want to say pentaoxide, that's okay too. And we're not supposed to say water. We should be saying what? Dihydrogen. How many oxygens? 1. So monoxide. Kind of odd. Water is dihydrogen monoxide, is the technical name for it. Okay, so know the names and symbols of the elements in the first 4 periods of the periodic table. Know the names and formulas of all the polyatomic ions. Know how to name ionic compounds. Know how to name molecular compounds. And naming is going to be on every single quiz up to our first exam. So let's run through a bunch of these. How do we name all this stuff? K is just potassium. How about K plus? K is in group 1, so its charge has to be fixed. So we don't use Roman numerals. You only use Roman numerals for the transition metals, because remember, their charge can vary. So don't use Roman numerals. So just potassium again. Same idea with calcium. Calcium is in group 2, so just calcium. Its charge is fixed. No Roman numerals for fixed metals. Here we have I minus. It has -1 because it's 1 away from the nobles. So remember, not iodine, but iodide. Cu is copper. Copper is a transition metal, so we better give it a Roman numeral for its ion. Copper 2, the charge. Nickel 2. Now these are trick questions. You remember when the charge of an ion is fixed, we don't write Roman numerals. So aluminum and zinc are the only 2 transition metals where their charge is fixed. So we don't write aluminum 3, we just write aluminum. We don't write zinc 2, we just write zinc. Silver is definitely a transition metal, so silver 1. Sulfide sounds a lot like sulfur. -1, -2. Oxide sounds like oxygen. -1, -2. Carbonate, our first polyatomic ion. Either you know it or you don't. Carbonate is a carbon, 3 oxygens, and a -2 charge. Recognize this polyatomic ion? Sulfate. Okay, now our first compound. Notice how there's no charge, so this compound is either an ionic compound or a molecular compound. If it's a molecular compound, you have to count to 10 in Greek. Okay, what do we look for? We look for do you remember? A metal. If you see a metal, it has to be an ionic compound. We definitely see a metal, right? Calcium. So that means name the cation followed by the name of the anion. So let's figure out what these ions are. This is definitely an ionic compound. So calcium has to have a +2, right? You can, if you're not sure, you can see the periodic table, or you can see the subscript right down here. Hydroxide has to be a -1 charge, so it's calcium. Name of the first cation. The name of the first ion is calcium. Second one, hydroxide. Another ionic compound, because we see a metal, so calcium phosphate. So calcium is Ca, phosphate, PO4 with a -3. Okay, what charge does calcium have? According to the periodic table, it's in group 2. I like to put parentheses around those polyatomics. Make the charges be the subscripts. So that means the 3 goes down there and the 2 goes over there. And you can either leave the charges there or just erase them. NaNO3, ionic or a molecular compound. Sodium, it's a metal, so name the cation followed by the anion. They didn't put parentheses around the polyatomic, but you can, if it helps you recognize them maybe. Nitrate, so that would be sodium nitrate. And the charges would just be a +1 and a -1. Potassium carbonate, another metal, has to be ionic. Potassium is K, and it's in group 1, so it has a +1. Carbonate is CO3 with a -2. I like to put parentheses around the polyatomics and make those superscripts, make those charges be subscripts. So K2CO3. Copper 2 sulfate. Copper 2, so that means a +2. Sulfate, it's an SO4, and sulfate has a -2. Right? So now we make the charges be subscripts. And with ionic compounds, this only works with ionic compounds. It's always the simplest ratio. So those 2's disappear because they're in 1-to-1 ratio. It's always the simplest ratio. Copper 2 chloride. Copper 2 chloride. Chloride has what charge? 1 over to the nobles, -1. So I'll have a 1 here and a 2 there. So that's CuCl2. Calcium oxide. Calcium is in group 2, so that's a +2. Oxide, -1, -2. Charges come down. Remember the simplest ratio for ionic compounds, so my answer is just CaO. Potassium sulfate. Potassium is a K+. Sulfate is a -2 charge. So the 2 goes down there for the potassium. K2SO4. Next compound. Do you see a metal? Phosphorus and chlorine are both nonmetals. So we have to count to 10 in Greek. We play that game. This is a molecular compound, okay, held together by chemical bonds. So monophosphorus, sometimes they drop off the mono, but I just keep it in. Monophosphorus, 3 is trichloride. Dinitrogen monoxide. Mono nitrogen. Dioxide. And you can leave off the mono if you want. Nitrogen dioxide also works. Dinitrogen. Carbon dioxide. Carbon, oxide, dioxides, you need two of them. Disulfur, dichloride. Disulfur dichloride. 4 is tetra, phosphorus. Remember, spelling counts. Tetraphosphorus, decoxide. And you can write decaoxide if you'd like. That's fine too. Silicon, tetra, fluoride. So name these and see if you agree with my answers. Ammonium sulfate. Make those charges be subscripts. So I'll have a 1 here, a 2 there. Aluminum sulfide. Aluminum sulfide. Remember, aluminum was that one that has a fixed charge of +3. Make the charges be the subscripts. So a 3 and a 2. Iron, it's a metal, so it's transition metal, so you have to give its charge in parentheses. How do I know it's 3? Because that 3 is right here. This is a 1, so hydroxide's a -1. Iron 3 hydroxide. Nitrogen trihydride. It's also ammonia. Monocarbon, or you could just call it carbon. Sometimes they drop off the mono. Monoxide. So, or carbon oxide. Drop off the mono on both. No metal, so you better count to 10 in Greek. Dichlorine pentoxide. We see a metal, so don't count to 10 in Greek. Aluminum see what's going on here? This 3 is from the +3. This 4 is from the -4. So what's C -4? Right? It's nothing surprising. 1, 2, 3, 4. That's carbide. Aluminum carbide. And no Roman numeral because aluminum has a fixed charge. Ammonium chromate. Ammonium is NH4. Chromate is CrO4 -2. So I need a 2 subscript there, and you can either write 1 here or not write anything, because if nothing's written, it means a 1. Lithium acetate. Lithium acetate. Lithium is in group 1. Acetate is a polyatomic ion, C2H3O2, with a -1 charge. Calcium bicarbonate. Calcium has a +2, it's in group 2. Bicarbonate is HCO3 negative. Let's bring the 2 down there. We see a dye, so no metals are present. This is the molecular compound naming method. So chlorine, and I need 2 of them, and I need an oxygen, but only 1. Sodium thiosulfate. Sodium thiosulfate is S2O3 with a -2. Sodium, remember, just in group 1, so that's a +1. So I'll have a 2 there, a 1 there, or just erase it. Potassium oxide. Potassium oxide, 2 there. Beryllium phosphate. Where is beryllium? Beryllium is in group 2, so it has to have a +2. Beryllium phosphate, polyatomic ion. So where do these charges go? Make them subscripts. 3 and a 2. Chromium 3 hydroxide. Chromium 3 and hydroxide. That just has a negative charge. Superscripts become subscripts. Do you see a metal? No. Dihydrogen sulfide. Potassium. What's ClO3? Chlorate. Perchlorate had 4 oxygens. Sulfur or monosulfur dioxide. Right, no metal, so use your Greek terminology. We see a metal, so, and lead is the transition metal, so make sure you write its charge in parentheses. Lead what? It has to be lead 2. And what is NO2? Nitrite. Nitrate has 3 oxygens. Now this is an odd one because oxygen should have a -2. So that means that there should be a 2 here, right? Because oxygen has a -2, but there's nothing there. So something funky is going on here. Let me show you. If this has to be a 4. This has to be a -2. Because then we would have Mn2O4. But it's the simplest ratio. That's how they get MnO2. So it's manganese, the charge in parentheses, 4 oxide. So there's a lot of naming. Just practice, practice, practice. Make those flashcards, grab an app, whatever you got to do. Get these names and formulas down for all these polyatomic ions and how to name ionic compounds and molecular compounds.